Well students, as we discussed in the previous class, we discussed about how the seeds are placed, what are the various methods of placing, what are the locations at which they should be placed, and what should be the spacing which has to be maintained, what are the various equipment or the devices which are available, and how the various operations are conducted, just in the basic aspect of what we have covered so far. Now, I would like to go into slightly details of the seed metering devices, because these are the ones which are very important devices. Here is your ingenuity of designing this system. If you want to design a good quality seed metering device, electronic operated one or a sensor operated one, which will just meter the seeds at their desired depth and desired location and desired pressing, etc., then you will find that the unit will be a economic one, it will be the best unit which we are looking for and all that. So, here you need to look into the design of such devices which are already existing, and what are the places where there could be chance of redesigning or thinking of innovations. Let us have a look at these. Bulk seed metering. Well, these are now the devices which are called bulk seed metering. That means, in the hopper we have the seeds placed, and from there now we are going to use these seeds, take the seeds either 2 at a time or 3 at a time or 1 at a time, like this. One of the methods is a stationary orifice. It may happen that in the seed, when you have the seed, you can have agitator, because once the seeds are there, they will maybe it will be difficult for the seeds to flow. So, there is need to keep agitating the seed bulk, so that there will be motion of these seeds. And if there is a small hole, say for example, if you this is what it is, there is a small hole, and this is operated in fact by a location. So, these are the seeds over here, seeds, and if this is this, so this is orifice which we are calling of orifice. So, this orifice, if you have orifice like this, simply change the position of the orifice and then you can get the seeds. One way of doing it, it is said that sliding the plate, hence the seed rate could be changed depending upon what you want. But this is the most you can say a crude way of sowing the seed. There has to be a proper channelized and better method of doing this operation. So, we have other types of metering devices which are fluted roller type. Now, this fluted roller type is given here. You can see this is the fluted roller. It is just like flutes, as if there are flutes here, and these are the groups. There are certain groups, long groups here, and this can be pushed inside this part where the seed is going, and it is going through the tube here. This is the inside the hopper. A hopper is here, from the hopper through the seed metering mechanism, then it will comes into this, and this is where. Now, this seed widely used in seed drills. In all the seed, this is one which is very popular and very widely used type of metering mechanism. Various type of seeds, wheat, gram, green gram, sorghum, soybean, many type. This is the one which is used. Fluted rollers are made of cast. The material of construction of this, it is very important to know, they are made of cast iron, aluminum or plastic. In fact, because the seeds when pass through this, there is every possibility, and most of the time we do find there is damage to the seeds when they pass through this. So, what we want is that there should be some softer coating onto these flutes, many the plastics which are made of plastics, or maybe some coating onto the plastic itself. Some designs are coming up, some manufacturers are utilizing these, so that there is minimum damage to the seed, because once the seed is damaged, it doesn't matter whether it goes there in the soil or not, because it will definitely not germinate. So, it is important that the seed reaches to the location in the soil at the proper depth in good condition. So, there should not be. Then exposure length ruler control by the seed rate. Yes, by the change of this exposure length, this is the exposure length here, and this exposure, by changing the exposure length, we can, which is exposed to the seed here. When we push this inside, then that exposure length will talk of the seed rate, changing the seed rate if you want. There are other ways of doing this, but this is one of the ways in this particular type of metering mechanism. Let us see what are the other types. Stud type, a very simple one being used long. Now, here the whole this is the hopper here, and then these are studs. These are studs over here on the periphery of this roller, and then these stubs they pick up the seeds in between like this, and then the setting flap is here, and this base flap, then they will be cutting, and then here the seeds will fall. This is the side view of this particular stud. You can have a look at this, but these are not very used. In fact, it is just like as if putting or arresting that much amount of the seeds within this studs here, there. So, within the height of the studs over the ruler, whatever is the amount which is taken from the bulk or the whole hopper, and then it will seed. It is definitely not going to give us a single seed, maybe a bulk quantity of seeds, but they are not very much in use. In fact, more refinement of such concepts have come up. We will see in the later course. Second one, drum type of orifice type, drum with orifice type. This is one device which we call as drum seeder. In fact, as we have seen that if you can sow the seeds in proper rows, maintaining a certain seed to seed distance and plant to plant distance, we have every advantage of getting a good crop. Now, in case of transplanting, particularly for paddy, we have seen that either we throw the seeds in the puddled soil. Puddled soil means the soil has to be well prepared for transplanting of paddy, and then we will do the thinning operation, and then we get the crop. But then if it is a transplanted one, we will definitely get a good strength, good stand of the crop, row to row and hill to hill. But if this is a very tedious operation, we have found that the amount of energy required in transplanting, in fact, we have done this right from transplanting. The first operation is that you have to grow the seedlings in a proper location, then they remove the seedlings, cut the seedlings, bring it to the machine, and then put in those in terms of trays, and then operate the machine. So, the total amount of energy we have found is quite high, although we do not get much weed infestation in such crops. This is there, but then we are losing lot of energy, and we have in fact scarce energy available for such operations, and that is why this particular device, which we call as drum seeder, this has been very popular for last 10-15 years. It is very much popular all over the country, and various designs have been developed and evolved. At IIT Kharagpur also we have evolved a design. Here what happens is, in each of these drums, in each of the drums, here the holes are made. These holes are made in these locations, and then this is the one where the seeds are filled. Here what we do, the seeds are first soaked in water, maybe about 24 hours or so, and then slight plumules when they come out of that, those type of seeds should be kept inside these, put inside these, and then this is pulled in between in the field itself, in the puddled field, where there is some amount of soil and mud is there. We would not like that there should be ponding water, just like in case of transplanting, but here we would like that there should be very little amount of water and muddy, so that when the seeds fall there, they should be in a position to stay and then grow over the period of time. But this has the beauty that it is giving you the same row to row spacing, plant to plant spacing, and even we have found that there are about 20% increase in the yield. So, compared to the energy spent in transplanting and this is found to be very effective, and the farmers are taking in a big way, they are going for this as an alternative for transplanting. Well, it remains that there are seed weed growth slightly more in this case, but even then it offsets the energy which has been used in transplanting, and so this device is very much popular in various parts of the world. It is known as drum seeder. Single seed hill metering devices. Sometimes we would like that either single seeds are metered, or 2 or 3 seeds in one location, we call hill. In one location there could be 2-3 seeds. So, when we want this to happen, we have some devices which are made. See, the beauty of these devices, I will just go through this for your information. Capable of maintaining over 100 millimeter seed to seed spacing, also known as planter. Well, we are in a position to maintain this. What is the beauty is we are in a position to maintain the seed to seed distance. This is the thing which we require, particularly when we are talking of planting. Various methods are there. One of the methods, if you recall, the stud one. The stud is there, the stud type of metering mechanism, there within the consecutive studs, whatever is the amount which is coming up. You can say that this has, if the stud is put in such a way that that means there is only one seed comes, then fine. So, a similar concept, if you see a vertical rotor here, you can say here the side view, you can see that this is the seed box, this is the seed box here, and this is the vertical rotor which these. So, here this vertical plate will have these small holes. Now, these are on the periphery. So, as this rotates here, they will be picking up the seeds within those cup sort of things here, and there the seed will move into this, and at this point of time this will be sown. The seed delivery will take place. This is a very simple one, and in fact good for very small seeds like mustard, jute and things like that. This is one. If you have a look at this is developed at IIT Kharagpur, and we can show you that how does it look like in the actual situation. This is how it looks like this. So, the top view, these are the locations where the seeds could be placed. These are the seeds which will be there in the hopper, and this will rotate and we get the desired spacing, etc. Horizontal plate metering devices. Now, we have talked of the vertical ones. Now, horizontal plate metering devices, it may happen that in the same seed hopper you have a horizontal plate, and that plate could have seed holding cups or seed holding locations, and that rotates. Now, question is, when it rotates in that, it may happen that the seeds may not fall. So, there has to be a device that device will allow a certain amount of seed. If I want 1 or 2 seeds, that the void should be, then it should have provision that it will wipe off the other seeds and only take certain seed, and then it will drop the seed at the proper location where it is. So, exactly that is done in case of this horizontal plate metering device. See, this is the this is the horizontal plate here, the hill drop, the flat, the edge drop. These are the different portions of these which are given. This is the top view of this. See, with varying size and number of cells are provided for different seeds and crop. Yes, depending upon this seed plate could be taken for different seeds. the seed, we know the seeds could be of different sizes, shapes and weight, whatever. So, for all these you can have different types of these seeds. The outer ring carries a cutoff device and a knockout device, as I said earlier, that when you have on the seeds lot of seeds coming up on the plate, lot of seeds coming up, then you would like that they should be cleared and only 1 or 2 seeds as I desire they should move. And when they move and come at the location where it has to be dropped, say heel drop, say supposing at this location, if this is the location, there should be a device here, a positive device which will simply drop it, or it will knock the seed down into the delivery tube, it will knock. So, these plates which could be of different cell sizes depending upon the crop which we want to do, and we will have 2 main important items. One is a cut-up device, the other is a knockout device. Cut-up device will brush up the extra seeds, and knockout device will knock the seeds exactly at the location where it has to go into the seeding tube. Inclined plate, this is another one. We had seen a horizontal plate, now an inclined plate. Each of these devices have their advantage and disadvantage. You will find that in case of an inclined one here, it is very simple. If it is inclined, there will be smooth movement of these seeds. It's true, definitely. It will be true. Maybe the construction is also simpler as compared to that. Maybe for bigger seeds you will require a different arrangement as compared to the other one. Have a look at this. The inclined plates rotates at an angle of 60 degree with the horizontal. They are kept are maintained at an angle of 60 degree with the horizontal. Seeds are picked in the cells and are dropped on the top of the inlet seed tube. Very simple, as generally it is supposed to have. Here is the seed here. There is a metering mechanism, because from the ground wheel we are taking the power for this. This type of metering mechanism is popular for sowing legumes, sorghum plants. Here there is a mistake for. So, this is good for these seeds, slightly bigger seeds, it is good for that. And the device is very simple. This is the seed metering plate, this is the seed metering plate here where the cells are there. This is hopper here, and from the ground wheel we have the bevel gear arrangement, because we know that this arrangement from here to there will be change in the direction of rotation of the metering shaft as compared to the direction of rotation which you get from the ground wheel. So, now there are certain things we say that certain amount of seed should fall, and we are taking power from the ground wheel, and we know that this ground wheel is of different level. It may not be smooth level at all the time, just like a flat ground or so. So, there could be some problems. We will discuss that slightly later. Belt with cell type metering wire. This is another device, and a very popular one. It has been used in very good machines, precision machines, because there the idea is that whatever is the seed, whatever is the type of seed, shape of seed, size of the seeds, you can take those seeds and have a belt running in the hopper itself. There could be a belt running in the hopper. I will show you. See, this is the hopper here, and there is a belt. So, there is a belt running here. You can see the belt running here. This is the metering belt with the holes here. So, you can have these holes which will help us in using these for different types of seeds. If you have one type of seed, you can use it. If you have slightly different types of seed, take a different belt, and this gives a very precise. We have to proper monitor the speed of this. In fact, such devices do have sensor based arrangements where we can inform the operator whether the seed is falling or not. just like one Stanhay seed drill which is used, which uses different type of belts. Just have a look at what are the main important things. Say the metering hole which we are talking of, this metering hole is equal to the size of the seed, and it is an endless belt. Yes, of course, an endless belt as I described here, that this will keep on moving, and as and when the seed is trapped and comes to the location, it will be knocked off at that place in the seed tube. The seed from the main hopper enter a small chamber above the metering belt and opening and remain at the control level. Yes, this is what it is, and then seed is delivered in the furrow close to the ground with terminal velocity to achieve proper seed spacing. Very simple, as I explained. This is one very important and very innovative device for metering of seeds at a precise location. You can call it a precision seed drill also. Cup feed metering mechanism. Well, we discussed earlier that this particular device, the way we have seen that when the in the hopper, when the seed, either the seed horizontal plate or inclined plate or any other arrangement, or you have a simple hole, constant hole, or a varying hole arrangement is made, you can do that. But we have also seen in the previous one that we can have small cups made of that, which we can cup fit type. That means cups are there, these cups will pick up from the hopper, they are also on the periphery of the drum, you can say, or a plate, and that plate rotates as per the rotation of the seed metering shaft, and then they will pick up those. This has been used. In fact, I had worked with this in somewhere in 80s, and I developed a cup feed type of metering mechanism for paddy, and can be used for any other seed as well. Of late this has also become very popular, and people are using this type of a device, a cup feed type. Here you can change the size of the cup depending upon the size of the seeds and all that. So, generally used, it is being used for is planting garlic, cloves, sugarcane, and bud planting, plantation, etc. I mean, these are being used for some of the special seeds. If you want, you can use this device, because this is another device. You have seen over the this discussion that we are doing that people have tried, depending upon the seed type and size, etc., various types of devices which could be used in these metering, in these equipment, and for ultimately for giving a good health of the seedling which grows and then grows into a good crop, and we get a good yield. All these arrangements are for that, and more innovations are coming up, because there are problems in these devices or the equipment when they are running in the field. We will talk of this slightly later. Pneumatic, this is one important thing, pneumatic metering devices. Now, here we would not like to have, you have seen that in case of the metering devices of either inclined type or a cell type or a horizontal plate, there is a chance that the damage of the seed could take place, because there is a cut-off device, then there is a knock device, there is a chance of that. Now, here the accuracy could be a problem. So, in order that we do not have to touch much of these particular seeds, a pneumatic device has also been designed, and this is very much popular. We have done at IIT Kharagpur also, we have done this work, and I am showing the same. This particular planter is air section in picking the seeds. This sucks the seeds while it is picking the seeds from the seed hopper. There is a suction created. Now, this is created by a blower which is used to create about 3 to 5 kilopascal of the pressure for sucking the seeds, and in the blower inlet chamber, which is connected to the vacuum disc of the planter unit. So, this is connected in such a way that when we are connecting the when the seed comes at a particular location, it is attached because of the vacuum which is there, and when the seed is moving at one location, it can cut off the device, it can cut off this device, and then the seed will fall. Here the beauty is that this device will give you 99 to 100% cell fill. That means all the cells will be filled up in the seed metering device, and then there will not be any missing. This is one aspect which has to be looked into by the designers, that the seeds which fall in all the seed metering devices, there must not be any missing. This is very important, and we must get a single seed picking up, and the efficiency of this system must be very, very good. This is important for the designer's point of view. Still lot of work is going on. How do we minimize the losses? How do we minimize the losses in the seed cells? I mean the filling of cells. Cells should be 100% filled. Calibration of the seed drill is very simple. Actually, if you want to calibrate a seed drill, or if you want to calibrate any device before you take it to the field, you must have an idea. What do you mean by calibration? You would like to see that if there is a seed drill, the metering mechanism is there, and that metering mechanism is taking power from the ground wheel. I have shown you earlier. So, when the power is taken from the ground wheel through a belt or a chain arrangement to the metering device, metering shaft. So, we would like that if this rotates for a certain rotation, what will be the number of seeds fall, because we have decided that for a particular crop in a particular area, or say per hectare, we would like that certain amount of kg of the seed must fall. So, in order to get that, we would like to try this in the laboratory and see whether it does or not. It is a different thing that when it goes to the field, there could be other problems, because of which there could be some changes in the value because of the wheel slippage, etc., which may come up in the seeds, and which do come up, and for that one has to take care of that. But then if we are not talking of that slip, then we should be in a position to know that if I rotate the seed drill wheel, what will be the number of seeds which fall. So, you can simply say that if in a hectare, if in 1 hectare so much of area, because 1 hectare is 10 to the power 4 square meter, and if the length of the strip is about W, then we know that this is the L which we require, the length of the total strip you require if you have width like this. And then to determine the total number N for ground wheel of the ground wheel seed drill to cover length of strip L, what will be the number of rotations N of the ground wheel. This comes out to be this. You can simply work out, there is nothing big in it. Jack the seed drill. Well, how do we get this thing then? You can jack the seed drill, and then in the laboratory, and take out the rotate for a certain number of durations, take the seed drills, maybe once or twice we do this, take an average of that, and then find out that if you have taken for 20 revolutions what you get, if you have done for 10 revolutions what you get, and accordingly for every revolution what you will get, and accordingly you will be in a position to get the seed rate which you want per hectare, using that in per hectare so much of number of rotations we will require. So, as I said, you should be in a position to get these values. Here we have given some of the seed rates just for the knowledge, maybe that if you go into more of literature, and depending upon what crop you are going to sow, you will find from the literature what are the seed rates which are employed, but we have given you for your ready reckoner that the wheat will have a seed rate of this much, rice has this for transplanting, maize, groundnut this value, mustard this is important, the potato so much kg, jute this, cotton this. There could be several others which you may get from literature, but this is what we wanted to show you, that how to calibrate a seed drill and what are the general seed rates for different crops. There is another problem which we wanted you to understand, because you have seen right from the beginning what is meaning of seed, what is meaning of planting, and how many populations should be there, what is seed to seed distance, what is plant to plant distance, etc. So, when you want to know this thing, let us have a problem here. It is a very simple problem. We want to find what is seed spacing when planting corn in rows 102 centimeter apart in the desired and the desired population is about 6,000 plants per hectare. At an average emergence of, it is very important that what is the level of emergence that we need, about 85% of that. So, if this is so, we would like to, what should be the seed to seed spacing? It is very simple. You know that there is 85% emergence. So, you must know what will be the total number of seeds which has to be available with us. So, yes. So, you will know that you require about so much of the seeds. This is seeds, because total number of plants need to be planted. No, in fact, you will have to have the seeds, total number of seeds are what will be required here. Because we know that if we have 100 seeds, then only 85 will germinate. So, the plants are, if 6,000 plants, so accordingly how much? So, we require this, and the area of this will be, then we can find out, which comes to 1.42 meter square area per plant, and accordingly therefore spacing comes out to be 1.39. If you calculate using this, you will get the values. Let us go to the other part of this. If the H drop seed plate has 16 cells and a diameter of 200 millimeter, what is the linear speed in meter per minute when the planting is at 6 km per hour? Here you need to understand what is the ratio between the forward speed of travel of the equipment or the machine with the tractor drawn or whatever is the power source, and the metering mechanism, the rotation of the metering shaft. So, we have to have a ratio between this. We need to get a ratio between this, then only you will find out this value. Well, here this is the linear speed. So, we want to get the linear speed. So, therefore, the linear speed is about 2.83 meter per minute of the planter here. Well, an 8-row transplanter operates at a forward speed of 0.25 meter per second if seeding space along the row is 0.25 meter and row to row spacing is 0.75, then calculate the required feed rate of seedling per minute by the transplanter here. Well, in this case, we see here that 8-row transplanter, there are 8 rows here, and the forward speed is 0.25 meter per second. Seedling spacing, seeding spacing along the row is this, and row to row spacing is this. So, we can very easily understand that the seed has a certain area which it covers, and that area could be, if you take care of the distances properly and try to understand, you will find that the seed is over here, and this to this is talking of this the spacing, seed spacing between, and this will be your row spacing. So, this being the information that you will gather when you go through the details of these seed to seed. If you are talking of here, this is a seed here, and if you are talking of a row, this. So, this to this distance as 0.75 and this to this distance 25 meter. So, if you consider the whole field, you will get something like this. So, which will tell you that the seed covers an area of this 0.25 by 0.75, and using this you will get the seedling per minute is about 480. So, therefore, the total number of seedlings required per minute are about 480 here. They calculate the required feed rate for seedling per minute by the transplanter. This is another problem which has been given. Now, question is that you have seen over the two lectures here that we had talked from the basics to the location of single seeds to bulk seeds to the transplanting. Then we will pick up more designs of this and advanced designs or precision seeders that we have designed. We will talk of those in the subsequent classes. Thank you.